This is actually our last lesson of our review unit. After this, we're going to get into quadratics. This is actually not, and the last lesson wasn't either. This lesson and the one yesterday were not review. These are actually new topics for you, like imaginary numbers. This is new too, but you're going to find that most of the skills we use are pretty much old school things anyway. So here we go. You guys are going to introduce you to what this thing called a complex number is, and then we're going to learn how to multiply, add, and maybe rationalize, but I don't know. We may not get to that. We'll see. All right. So go ahead and copy down this slide. All right, John, be with us. It's okay. I'm going to talk about it a little bit. So, quiet, please. Michael, I'm trying to teach right now. Just a second. I want to teach right now, okay? So I want to teach right now. All right. So, what is a complex number? A complex number is the sum or difference of a real number, which I'm going to represent with the letter A, and an imaginary number, which could have a real number next to it, but it's B with times I. So this is what we call a complex number, okay? So this is actually the thing that makes imaginary numbers useful in physics and stuff, is they use this. They use this to model electromagnetic waves. I don't really know much more than it has something to do with the fact that there's two forces working in opposite directions, and they use one to represent one and the other to represent another, and it just so happens to work really well in calculating the outcome. So that's the most I can say about it, because I'm not really into that field of study, but I looked into it a little bit. But our goal today is just going to be to learn how to simplify these by adding and subtracting and multiplying. So let's go ahead and write down number 1, please. And the good news is even though we're working with completely different numbers than we've ever worked with before, the rules are exactly the same, so you guys could probably do this without me even showing you. It's just like combining polynomials. So I want to add this complex number to this complex number, and the way you do it is by combining the real numbers and you combine the imaginary numbers. So 3 plus 4 is 7. That's my real numbers. And then 6i plus a negative 2i. What's that?
Negative 4i squared.
Positive 4i. And it's not squared. It's just like when you add polynomials, you just add the coefficient but keep the variable the same. So there it is. And the same rules apply to subtracting complex numbers, okay, as they do with polynomials. Do you guys remember what you have to do first before you can combine when you're subtracting polynomials? Distribute the negative, right, and it changes the signs, and then you just combine them.
Yeah.
So go ahead and write down number 2 if you haven't done so yet. I'll wait for you a little bit.
Are you drinking actual delicacy? No? Okay.
Yeah, I would throw up. Wait.
No. All right, so the first thing I'm going to do is I'm going to distribute this negative. I'm going to treat it kind of like a negative 1 that I'm multiplying inside. And what that's going to do is the first set stays the same, right? 3, 8i. But the second set's going to become what?
Positive 2.
Positive 2 and?
Plus I.
It just changes their signs from negatives into positives or vice versa. All right, now we combine the 3. The 3 combines with the what?
2, 5.
And the 8 combines with the I to make
8i squared. Oh, 9i.
9i, because you want to think of this as a 1. And once again, when you're adding, you add the coefficients, but you don't change the variable. Now, I is not a variable, but it acts like one. Yeah.
Why does I have a number, but i's originally negative 1? Why does it have a number first?
Because it could. So like, for instance, instead of writing this, I could write this. it means the same thing.
Okay.
Okay. All right. So that's adding and subtracting. Now we're going to throw in multiplying. Okay? Multiplying is a little different. So you guys ready? Write down number 3. The air conditioner makes the whole floor shake. So it's like I'm always wondering if there's an earthquake.
That's what that was?
Earthquake.
Yeah, the air conditioner is pretty rough.
It makes the board shake and it makes my eyes really busy.
Wait, what shapes?
A little bit. Okay, so we have 1 minus I times 2 minus 3I. Now this, once again, is just like polynomials. There will be a little twist at the end, but for the most part, it's just like polynomials. So, how did we do this? We did the old box method, didn't we?
We have to do that?
1 minus I and 2 minus 3I. By the way, how can you tell numbers 1 and 2 are adding and subtracting problems and number 3 is multiplication? Yeah, if there's a sign in the middle, you're just adding and subtracting. But if there's no sign, that's a box method problem.
Oh.
Okay? So let's fill in our box. What goes here?
2,
How about here?
negative 2I.
Here?
Negative 3I. Negative 4. Wait, what the heck? Yeah, because negative plus a negative.
We're multiplying.
Oh my gosh.
So what's negative 3 times negative 1?
3. Oh my gosh.
No, it's 3.
Is 3.
I said
What's
four.
I times I?
I swear.
I squared.
Gangsta.
Okay, now we go ahead and take everything out, right? And we put it in order. So we're going to put this one first.
Isn't it 2 minus 5I plus 3I squared?
Yes, so we combine these. Now, remember, when we're doing this, now we're adding, right? So you combine the coefficients, but keep the I the same. So what's negative 3 combined with negative 2? We're not multiplying, we're adding. And then, and the I stays the same. And then this guy comes out as is as well. Right? Now, here's where the twist is. Remember I told you it's going to be just like polynomials, but it's going to be a little twist at the end? Here it is. You guys know that I squared is what? It's just a normal real number, negative 1, right? That's what's different. So we're going to change the I squared to a negative 1, and now we can go a little bit further. What's 3 times negative 1?
So it's 2 minus 5I plus negative 3.
And now I can combine the what and the what?
Like the 2 and the 3.
The 2 and the minus 3, which are?
Negative 1.
There you go. So that's where the complex numbers get a little different than polynomials, but the process is the same. Just remember to replace the I squared with a negative 1. Okay? So it's almost like just doing polynomials all over again. But we got to remember, you know, this is not really a variable. This is a number. It's an imaginary number. But the way that it acts is just like a variable in polynomials. All right? You guys got any questions before we set you to work on some? Mm-hmm.
Already?
Okay. So here's. Oh, me too.
Get out of here, dude.
Here's a couple for you guys. Show me what you got. Oh, Chris, you probably didn't do that yet, so I'll come to you later. Kendall, what did you get for number 1?
For number 1, I got 9 minus 8.
Okay. Any questions about number 1?
No.
Okay. Let's go ahead and take a look at number 2. Leslie, what did you get for number 2? No good? Anybody want to take me up on that one? Go ahead, Kenneth. I got Kenneth. Just the answer. Good. Okay. So I will I will offer to go through that one because somebody didn't know it. So this one, you're going to distribute your negative here, which is going to change our problem to be negative 5 plus I. And the 6 becomes positive now, and the 7 becomes positive. And so when you combine these, this makes 1. And 1I and 7I makes 8I. And so that's why it is correct. All right, let's go ahead and move on to the last one. Annie, what did you get for number 3? Okay. Someone want to take me up on that one then? Go ahead, Micah. What'd you get?
13.
The answer is 13. So if you didn't get this, you might want to write it down because this is actually an important problem that's going to help us understand the next part of our lesson. Yeah. All right, so first of all, it's a multiplication problem, isn't it? So we're going to do the box. Now, as I came around, I saw a few errors, like people didn't put their eyes on there. And the more common one is people didn't make sure that one of their 2 eyes was a negative. You got to watch out for that. All right, 3 times 3 is 9. 3 times 2 is 6. Negative 2 times 3 is negative 6. And negative 2 times positive 2 is what?
Negative 4.
And then I times I is? What happens here? Those are gone. They're opposite signs, right? And so here's what I'm left with, but we can go further. So I'm going to ask Paris, what am I going to replace the I squared there with, Paris? Huh? Paris? What am I going to replace I squared with? Oh, yes, a negative 1 actually. And then Micah, what does this become then? Oh, I said the wrong name, but yeah. Okay. 9 and 4 make 13. Now this is an important problem. Let me tell you why. We started off with 2. Raise your hand. Can you tell me what those things are called?
Oh.
We started off with 2.
Imaginary numbers.
No.
Oh.
Nice. Koi got it. All right.
Really?
Complex numbers. We start off with 2 complex numbers, which are basically, they do have an imaginary part to them, though, Hannah. Now, here's the thing. What did I end up with, though? A regular real number. Okay, so this is important for our next thing coming up, so you might want to make sure you pay attention. When you multiply 2 complex numbers that are exactly the same, except one's a positive and one's a negative, we've done that before, haven't we?
Yes.
I think one person in here that I noticed remembered the shortcut. You guys remember the shortcut for a plus b times a minus b?
Oh, what is that?
You just square it, the first number, you square the second number, and you put a minus between them. So we could have avoided the box, right? But something special happens there because when you square an I, it's no longer an I, is it?
9 plus 4.
So you get a real number, okay? So if you ever have a complex number and you want to get rid of the I, the way you do it is you multiply it by itself, but with an opposite sign, okay? And that'll take care of it. It'll cancel out the I. All right, so that being said, let's move on to the next thing then here. So what's wrong here?
The eyes on the bottom.
Can't have an I in the bottom. Now, let me you don't need to write this, but let me show you what you can't do, because we did some of this yesterday. Some of you guys might think, well, I'm just going to go ahead and multiply the top and the bottom by I, because that's what we did yesterday. The problem is that's not going to work. Let me show you why. 4 times I is 4I. That's cool. I times I is 2I squared, which is good, because that's just going to change it from a negative 2 into a positive 2, right? But the problem is that I has to go to both. And now I just put another I on the bottom over here, though. So what are you going to do now? You're going to do it again? If you do it again, it's just going to put it back on the 2. It's just going to keep going back and forth. It'll never stop. So we need another way to cancel this out. And here's how it is. Here's the thing. This is not just an imaginary number. What is this? That's a complex number. And if you want the I to go away with a complex number, what do you multiply it by? By itself, but with an opposite sign. And we just did that on the last slide, didn't we? This thing times this thing. What did the two bottoms come out to equal? This times this made what? But we got the final answer. What was the final answer? It was just 13, right? The top, we can distribute here, and you get 12 plus 8i, and now you're good. You don't have an I in the bottom anymore. Okay? So that's the strategy that we're going to employ for this. So when you have just an imaginary number in the bottom, you just multiply the top and the bottom by I. But when you have a complex number in the bottom, like a binomial, you multiply it by the same thing but with opposite signs. By the way, that's called a conjugate. It's the same thing but with opposite signs. We call that a conjugate. I don't know if that's a vocabulary word we're going to write down or not. Let me see. I think it might be. No, it's not. I didn't. So don't worry about it. It's not a big deal. But let's go ahead and write down example 2 here. Number 1. Example 2, number 1. I don't remember. 5 over
3 plus 4.
Okay. I want to cancel out the I, right? So I need to multiply the top and the bottom by something. See if you can figure it out. I'll give you a few seconds. We just talked about it.
Why is there an almond on the floor?
Because
Is it your stuff?
it used to be a half month, but then I found another half month and became an almond.
Oh my gosh.
Don't judge my jokes.
What happened? What?
All right, I'm gonna ask you,
That's my snack for later. I was like,
Kiara, what am I multiplying by?
Oh, there's
yeah.
Beautiful. Same exact thing, but a minus here instead. Okay? And whatever you do to the bottom, you have to do to the top. Okay, so I would highly advise you guys use the shortcut, right? I can do the shortcut down here. Remember the shortcut? You just square the 3. What's 3 squared? And then you square 4i. What would that give you?
16i squared.
Yes. 4 times 4 is 16. I times I is I squared. And it's a minus. Remember the shortcut? Yes? Oh.
9 plus 16. Oh, my bad.
Now, let's go ahead and do the top. On the top, you actually got to do a little bit of work. You got to distribute. So what's the top going to be?
15 minus.
Now, we're getting there. But we're not quite there, because what else can I do here?
You can make the bottom so bigger than 9 plus 16.
That's right. The I squared becomes what? -1, which means that it's going to become 9 what?
Plus 16.
And you guys don't have to show every step like I am when you're doing your own work. I just do this for notes. And therefore, we end up with 5. Now, I'm going to throw one thing at you that you probably didn't see coming, but go ahead.
Oh, I need to divide it.
Yeah. Yeah. Here, I'm going to do something a little bit different, but it's like that. So check this out. Here's how we're going to write it. You ready? You can write it like this, but I'm going to split this up into 2 separate fractions. You do 15 over 25 minus 20 over 25, and then you put the I off to the side there. And then, of course, you want to reduce if you can. Okay, so and this does reduce. So what goes into the top and bottom here? 5 goes into 15 and 25.
4 over 5.
Now, the reason I'm telling you guys to split it up like this is because now it looks like a complex number, doesn't it? A plus bi. So that's why I like to write it like that. It keeps the form right. Huh?
The 25 on the bottom of both of them, right? It's just one.
So let's review. We started with this, right? Then we multiplied it by its opposite. And we used the shortcut to do the multiplication, right? We simplified, and then we split it up and simplified. Okay? Let's throw one at you and see how you do here with it. I don't know. I tried tossing and it doesn't work out so well. All right. So step one, go. I'm gonna call on you in like 30 seconds for step one. I'm holding. Not currently, but you can talk to your home gal there, or your home boy. Feeling unjudged.
Yeah, they're all good.
Well, then watch. All right. Are you ready, Alicia? Do you know what the first step is? That's right. Multiply the top and the bottom by 2 minus I. Good. All right. Now I'm going to ask you to simplify the top and the bottom. So that's going to be my next step to ask of you guys. And I would encourage you to use the shortcut for the bottom. Don't do the box method. Use the shortcut. It's faster. Yeah. LaFontaine, what's the top become?
That's all I do?
No, not yet. Does somebody want to pick that up for me? Let me go Danielle. I've talked to Danielle today. Go ahead, Danielle. You distribute. So what would you get?
4 minus 2i.
You would get 4 minus 2i. All right. Let's do the bottom. Hannah, what do we get on the bottom?
I don't know. This is as far as I got.
What did you get?
Nothing.
Okay.
Oh wait, what?
I haven't talked to David today.
No, wait, stop. You helped me with that.
Go ahead.
4 minus I to the I squared.
Okay, so the shortcut is you square the 2, you square the I, and you put a minus between them, right?
Yeah.
Now, on the bottom,
There's more?
yeah, we're not quite there yet. Nelson, what's going to happen here? So I squared is a negative 1, so we're subtracting a negative 1. So what's that going to become? Plus 1, and therefore we have this. Okay, so my next thing is I want you guys to write the final answer because we're not quite done yet. You have to split it up, right?
So it's not quite that.
No.
And then you always want to simplify down and break this one too, or
I would, yeah. I would do that.
What? Wait.
What's an arrow, in case you're wondering? We're going to rewrite it. Okay, so like I said, guys, we're working on this one, so try to do the whole thing. All right,
Hang on.
we're going to try to squeeze one more in here.
Hang on.
We won't do like a student practice. We'll just kind of do the last one together and call it a day.
Can you? I don't understand that.
Sure. Go ahead and write down number 2.
Wait.
hold on. Before you do that, we gotta have a use.
Well, we're going to walk through it together, but so just patience. All right, so I'm going to ask John, what do I do first here, Chavez?
Multiply 5 plus I.
Good. Now I'm seeing a couple of you guys as I come around not changing the sign. Make sure you are doing the opposite sign when you do this. So that is correct. Oops. Okay. So now the bottom is pretty good. If I did the shortcut, Adrian Canizales, what would I get on the bottom if I did the shortcut? Yeah.
You get 10. 25.
25.
And 25 minus I squared.
Good. Now I squared is going to be what? That's negative 1, right? And since this is negative 1, it's just going to become what? Plus 1 because of the minus there.
That's really a question. So you see at the top is like that, and it's multiplying. Do you have to make a box?
Yes, that's
I do it. Oh.
I saw some confusion with that last step, so I'll go ahead and write it out here. So 25 minus a negative 1 becomes 25 plus 1. And then we have 26, right?
Wait, what are you doing? Why are you working backwards? You're confusing.
All right. Now, we haven't done the new part, though, what makes this problem different. And Danielle kind of hit the nail on the head when she asked the question. She said, how do you do the top? And what do you guys think the answer is?
Don't you just multiply it all?
You do the box. You do the
So
box.
Bailey, why'd you work backwards?
Wait, you do the box just for the top?
Or I had the board
Just for
screens.
just for the numerator?
Do I what?
You say we just do the box for the numerator?
Yeah. You can't use the shortcut here because they're not opposites, right? So we actually would have to work that out. So I'm going to go ahead and do that, and then that'll end our problem. But that's the big aha. There's sometimes you'll have to do a little bit more on the top if it's already a complex number. So
Oh my lord. This hurts. Like my soul.
So I'm going to put negative 3 minus 4i on the top. And I'll put 5 plus I down the side. And we just go ahead and go about our business here.
Okay, I got a problem, but like, I don't know if it's the right thing. So it's like, can I show you?
A little busy right now, but maybe in a second. So the negative 15 comes out. Negative 3 and negative 20 makes negative 23i. Right? And then this is negative 4i squared. What does this become, you guys?
Positive 4.
That's right. And then the 4 combines with the what?
With 15, which is a negative 9 minus 20.
Okay, so now, here's what I have. On the top, I have negative 9.
No, that's negative 11. Negative 11. Correct.
This is negative 11? Okay, thank you. So that means the top simplifies, this part I boxed here, that becomes negative 11 minus 23i because of all that work I did over there. What's the last thing we would do?
Actually, I think you made a mistake. That's supposed to be a plus 4 up top. That's supposed to be
Okay, Mr. Bailey,
when you did the box, you put minus 4i instead of plus 4i.
It's
on the
plus
top.
4. It's supposed to be
I
17.
had it right the first
Negative
time.
15.
Stop. At the box.
So these were all pluses, is what you're saying?
So at the box, you see how you put.
Wait.
I do.
Oh, can I go up there and show you?
No. No, I'm good. So they're right. I'm just going to leave it since we're kind of close on time, and I'm just going to pretend that was a minus because I don't want to go back and do it all again. But I see what you're saying because that will change everything if I go back. So let's just say we're here. What would I do next?
From there, you're going to split it into how you did it. Which would be negative 11 over 26 minus 23 over 26 with I.
That's it. So, yeah, I made a little boo-boo here. I would say we should probably just, to make this a little bit easier, you might want to just go back. If you're copying my work, just go back and change that to a minus. And that way we can say it's all good. All right. So that closes us out for the day. Now tomorrow, guys, is going to be a review day of our review lessons. So, and then Thursday is going to be our test on all the stuff we've been learning.
Oh, but you're going to do the whiteboard stuff?
I don't know. Let's see.
This is a lot of stuff. This is the whiteboard stuff.
That's why we have review days.